This video we will see some more examples of conditional if. So here first of all define a variable n, and here enter number, so here first of all we want to check if this number is divisible by 5 or not. So if n mod 5 is 0, here within this if block we are just displaying divisible, and else not divisible. Suppose it is 10, you can see that the number is divisible by 5. Suppose in the same, if we want to check if this number is divisible by both 5 and 7, then what we will do? So here in this case we will use this logical operator and the purpose of this and is it returns true if all the given conditions are true. So if this n mod 7 is also divisible, so here suppose this number is 10, so it will say it is not divisible by both the numbers 5 and 7. But if it is 25, it is not divisible. But if it is 35, this given number is divisible by both 5 and 7. So this is how we can just use this and operator with conditional if. Now here we can use or operator or also. And what is the purpose of this or operator? The purpose of this or operator is if either of the condition is true. So here, so we can check if any number is divisible by either 5 or 7. Any of the number. Suppose it is 7, yes, it is divisible. And here if it is 5, then it is divisible. But suppose the number is 9, it is not divisible. So this is how we can use or operator also. Or is again a logical operator. Okay. Now here we are going to see one more example. This time, children, we are going to input a real number, floating number, and we want to round off it. Suppose the number is 12.34. The number will get rounded to 12.0. And here if it is 12.51, it will get rounded to 13.0. So this we are going to implement using conditional if. So first of all, here just input this number num, just have one variable num, and here we have another variable which is fractional part, and we have another number, another value which is real number part. So first of all enter the number. So here suppose we have entered the number like num is, which is ss dot next double. So we have entered this number. Now see that here the number is 12.34. Yes, it is entered. And now if we want to extract the real number part of this, it means integer part of this, so that is rp is int num. What is this? Children, this is explicit type conversion. In previous videos you all must have seen this. So here just I'm going to input this, print this rp. Suppose the number is 12.34, so it is 12 only. So this is how this 12 has we have extracted, which is And now we have to extract the fractional part. So how to extract? So fractional part, which is fp, is equals to num minus rp. So if we print this fractional part, it will be fp. So here just 12.34, you can see that it is 0.33. Or one thing we can do is that if it is float, and here if we are writing this float, okay, here just go through this 0.0 f as the actual initialization of this. Execute this part. 12.34. Yes, we have got this 0.34 as the fractional part here. So exact value we have got. So in case of double, actually it was not returning that value, but here explicit type conversion, again subtracting the integer from the double type variable, which is num. So children, now we have to round off. So the question is how to round off. So if the fractional part is greater than or equals to 0.5, then definitely we are going to change this num, or for this we just define one more variable, which is the copy of this num. So if it is more than this, so copy will receive num plus 1, not num plus 1, rather than it is rp plus 1. And if it is not the case, then copy will receive only rp. So let us see that. Rounded value is, which is copy. Let us execute this. It is 12.34. So the rounded value is only 12. So, and if it is 12.51, you see that the rounded value is 13. So this is how you have this is how you can perform this. You can round off any fractional, any floating point number like this. Children, here I would like to explain one more time this one. Suppose it is 12.34. So if you perform this explicit type conversion, so this 12 will get extracted and will get stored in this variable rp. And here now it is 12.34 minus 12. This 0.34 will get stored in this variable fp. So if fp is more than 0.5, which is not in this case, so the answer will be 12.0. But if it is 12.54, in that case it is more than 0.5, which is 0.54. If you extract this part, it will be 0.54. So 12 plus 1 will happen, which is 13. So this is how we have rounded off. Now children, here in this we are going to see one more example, and this time we are going to receive three sides of the triangle. And we want to check if the given triangle is a right angled triangle or not. So here for that we need three variables. So first of all, it is side 1, side 2 and side 3. and one variable small is needed, and one variable large is needed, and one variable middle is needed. So actually this large I have taken for the hypotenuse, and this small I have taken for the base, and this mid I have taken for the height. So I will be checking this with the help of Pythagoras theorem, children. And I hope everybody is knowing that Pythagoras theorem. So first of all, enter three sides of the triangle, and the first side is ss dot next anti, and now the second side is which is this is the second side, and now the third side will be ss dot next anti. So first of all we have to find out the small, large and mid. So in order to find the small we will be using math.min, and here math.min side 1 comma math.min side 2 comma side 3. So in one of the previous video you have seen that. So this is how we can find the smallest number among these three. And now here another variable is needed, which is math.min side 1 comma math.min side 2 comma side 3. So this is it is not min, sorry, it is math.max max. So this is how we have got the largest also. So it means we got the hypotenuse and the base, and now the height. So which is the middle part. So side 1 plus side 2 plus side 3 minus this is small plus this large, and here we have got the height also. Now I am going to use the Pythagoras theorem. So how to use that? If large into large matches with small into small plus mid into mid, if this given condition is true, then it is right angled triangle. And if this given condition is not true, then else part will get executed, and it is not right angled triangle. So it is simple that if this given condition is true, then this block will get executed, and if this given condition is false, then this else block will get executed. And I hope you have understood this concept. I hope you have enjoyed this video. Thanks for watching.